So here we see the setup job page in the Alloy Qualification Toolkit. So the first thing you need to define is your sampling method, which I just reviewed. But then the next thing you need to define is the composition. So compositions can be loaded from compositions you've defined previously or compositions you've used in other toolkits. And in AQT, they can also be loaded from specifications, which are compositions that have defined ranges for each of the elements. So here you can see I've set up the M54 steel composition. If you wanted to add an element to a composition, you just need to click here, and that will pull up a periodic table where you can choose the element you want to add. So you can see currently everything is defined in terms of single values, but one special thing about the Alloy Qualification Toolkit is that you can select global variations here. So you can see we have two choices, uniform or normal. So if we select normal, you've seen those single values have been turned into means and standard deviations, which you can define for each one of these elements. If you choose normal variation, uniform variation, the parameters become a minimum and a maximum that you can define for each element. So you just go in here, change values of the minimum and maximum. And if you want, you can even change the distributions per element. So you can mix and match uniform and normal distributions. And you can also disable the distributions of certain elements if you only want to focus on the uncertainties of a few elements. So after you've defined your composition, you can start adding models. So that's done here in the model workflow page. So you can add a model here. We have a variety of models that you can add that cover a wide range of microstructures and properties. But typically the first model you add in a model workflow is a process model. And we have lots of process models that cover most conventional processing techniques. What I'll be showing here today is a precipitation model, which is useful for modeling aging and tempering processes. So here you see we've added a precipitation model, and the inputs for that model you can see are broken up into required and optional inputs. Some of the required inputs have already been filled from the global definitions that are set higher up in the page, but I'll just show you how you go in and fill in some inputs here. You notice that for this input, precipitous, there's a lot of optional inputs that users can play with if they want to, but I'll just skip that for now. And then the last thing you need to define in a precipitation model is a temperature profile. So this tool I'm showing here is interval based. So you just define each interval of your temperature profile separately. So once you add an interval, it will bring this up, which lets you define an initial and a final temperature, as well as some definition of time, either a duration or a rate. I'll set this particular interval to isothermal. And you'll see here that for the temperature variable, we have three options. And one of our philosophies in ICMD is to provide the user with a lot of power in how they use their inputs. So for most of our numerical inputs, we have three options. So from user, which is very simple, users just provide a value, and if it's applicable, a unit to that input. We have from model, which is where users can use the outputs of one model as the inputs to another model. I'll show an example of that in the next slide. And then lastly, we have what's called from certainty in the Alloy Qualification Toolkit, or from variable in the Alloy Design Toolkit. And this really lets users choose any input, whether it be a process input or a model parameter, to study the uncertainty and propagate that uncertainty to model outputs in their model workflows. So here we'll choose this this temperature to be an uncertainty variable, and we'll create a variable here just called tempering temperature. Here we just need to define the unit and a distribution, so we can choose between normal and uniform. Here we'll just use a uniform distribution from 510 to 520 C, which is representative of maybe like 515 C temperature setting on your average furnace. And so next we'll define the duration. So here we'll just choose something simple like 10 hours. So now that we've added a process model, I'll go over how to add another type of model. So here we'll add a property model, a yield strength model. And we'll see the very first thing we'll do is we'll pull the matrix composition from that process model that we just defined. So we'll choose the precipitation model, choose the relevant output, and that will be the input matrix composition to the yield strength model. We'll also define a grain structure. We'll just set a representative value here. And then for the precipitate information, we'll select the precipitate that we know forms in this material, the M2C carbide, and we'll take the radius and volume fraction of that precipitate from the precipitation simulation we just set up as well. So you can see how that's done. And so you see in the model workflow page, once you've connected a model this way, when you're pulling the output of one model to use as the input of another model, they're connected with an arrow. And this is to help users understand, the exact connections between models and their workflows.